We'll see a few different types of ions before we're all done naming ionic compounds. And the simplest of these are our monatomic ions, or the ions that elements on the periodic table are going to form. Even some of these are a little complicated, like the transition metal cations, but luckily our main group elements adopt characteristic charges so they're easy for us to use. Knowing why an element adopts a certain charge when it forms an ion makes it easier to remember those ions. We won't talk about subatomic particles until section 1.1, but for now, know that an electron has a 1- charge. Anytime an element gains electrons, it becomes more negative and it forms an anion. Anytime an element loses electrons, it becomes more positive and it forms a cation. We'll discuss the periodic table more in section 1.2, but for now, know that there are 8 columns that we focus on when we discuss these characteristic charges. This larger group is going to be made up of the first 2 columns and the last 6 columns. These tallest of our columns make up what we call the main group. While we will use the transition metals, or that middle block of the table, the main focus of this course will be these 8 columns, as they have more predictable properties, so they're easier for us to work with. One of those very predictable properties is the charge on the ions formed by these elements. A main group ion's charge is predictable because all of our main group elements are working to have the same number of electrons as the very last group to the far right of the table, which are referred to as the noble gases. There's usually only one good way for an element to get to that number of electrons. Let's look at lithium. Lithium is located in group 1, or the very first column, referred to as the alkali metals. The 2 noble gases that it is closest to are helium and neon. In order for lithium to come up with the same number of electrons as neon, it would have to take 7 steps forward, gaining an electron each time and ending up as a lithium-7- anion. This would involve an incredible amount of energy for our atom, and our atoms always want to minimize the energy it takes to do anything. In order for lithium to come up with the same number of electrons as helium, it would have to take a single step backwards, losing a single electron and becoming the lithium plus cation. The second option is much easier for lithium, as it's much more energetically favored. So lithium forms a cation with a 1+ charge every single time, no exceptions. The glory of the main group elements, and the reason we focus on them, is that everything in the same column is going to tell similar stories because they all have similar properties. So everything below lithium, and even the hydrogen atom above it, is also going to form a 1+ cation. No exceptions with those metals, though hydrogen can also form a 1- ion. Let's move to group 7, or the column just to the left of those noble gases. Fluorine is the first element in this column on most tables. The noble gases closest to fluorine are helium and neon. An atom of fluorine would have to lose 7 electrons to get the same number as helium, which is very difficult. So instead, it gains a single electron so that it can have the same number as neon. This gives fluorine and all of the elements below fluorine a 1- charge when they are ions. You will occasionally find a periodic table that duplicates hydrogen's entry on the table right above fluorine. Hydrogen can gain an electron, like fluorine and the rest of the halogens, and it can form an anion with the same number of electrons as helium. As mentioned, it can also lose an electron, at which point it has no electrons. It will only have the single proton in its nucleus in this positive case, which is why the hydrogen ion is often referred to as a proton. Elements in the second column have a choice of gaining 6 electrons or losing 2, so it's easier for them to lose those 2 and form 2+ cations. Moving across the transition metals to that boron column, this column could either lose 3 or gain 5. It's easier to lose 3, and this column has a characteristic charge of 3+. Do note that boron tends to form molecules and non-ionic compounds, so you're really not going to see it with a charge, and that 3+ applies to aluminum and below. Carbon and silicon technically could gain or lose 4, but for our purposes, we will give these guys the positive charge and call this our 4+ column. Once we get past carbon, it's easier to gain the correct number of electrons than to lose them. So in the case of nitrogen, it will gain 3 electrons because it is 3 steps away from neon. Everything below it will do the same. So this is our 3- column. Lastly, the column with oxygen will take its 2 steps towards neon and gain 2 electrons. This gives this whole column a 2- charge when they form their ions. The noble gases don't gain or lose any electrons because they're already the model that all of the other elements are trying to follow. This means that we will not see ions of the noble gases. We will see a few molecules of xenon later in the term, but we will not see ions.